And hi everyone, welcome back to our channel. Today we are going to be doing another geometry set. Lesson 1, Chapter 7, quadrilaterals, and then Chapter 7, quadrilaterals as 2, and then we have set 1. Be sure to hit that like button, comment, and in the last video I said, when you guys comment, tell us how we can make our videos funner to watch and just better. So guys, I hope you enjoy this. I'm going to be trying to cut my videos more so I can do more hand things. But anyways, be sure to watch our other videos. So now let's just get on with the video because I just did my intro. So set 1, lesson 1, chapter 7. Here we go. Okay, now I'm going to explain our lesson. Let's go. Okay, so it's called quadrilaterals. They give us, which I'm about to show you, pictures of triangles, and this main shape of the lesson / theme is rectangles and squares and kind of triangles, but rectangles are the most important. They asked us a lot of right angle questions and how they equal. I'm going to show you our definitions and theorems and corollaries, and then I'm going to explain to you our actual thing. Okay, first definition. A diagonal of a polygon is a line segment that connects any two non-consecutive vertices. Theorem 24. The sum of the angles of a quadrilateral is 360 degrees. So if it's going to be the sum, which would be 4 angles usually I'm saying, doesn't mean to be, like a triangle sometimes can have the sum. No, that's not it. But anyway, so what I'm saying is that usually in rectangles and squares they have right angles, and then 9 times 4, 36, and a 0, 360. So that's kind of the theorem, just giving you like a little basis. Next definition, a rectangle is a quadrilateral, each of whose angles is a right angle. Okay, now we're going to do our corollary to Theorem 24. A quadrilateral is equiangular if it is a rectangle. Okay, now I'm going to explain, and I'm going to show you the set. So a reason why, and I just showed you kind of the theorem, which kind of gave you a nice flat outline for you to understand that they're going to be asking us a lot of questions. They're going to put a statement, and then it's going to be and why, or just why. And in the photos you guys will see, but I'm going to give you their statement so you guys know how they're doing it. And then I'm going to show you guys a few examples that are going to move into the next little set. This one's called Theorem 24. Complete the following proof of Theorem 24 by giving reasons. The proof is written in paragraph form. The sum of the angles of a quadrilateral is 360 degrees. I just realized I forgot to show you. And also, another important thing is in the intro of this paragraph / new chapter is how there is this awkward shape from a window and you guys see, but I'm not going to read it right now, but from a window that gave them idea of this lesson set. And see all the extra triangles, rectangles, so cool. Okay, now I'm going to show you the other one because that's what I want to show you. See, these are the triangle, like rhombuses, rectangles, all the cool shapes. See? And then there's they split it in half as a diagonal. 1, 2, 3, and 4. Okay. Sorry guys. Okay, I'm going to, so they have a given and proof. They have the given. A, B, C, D is a quadrilateral. Proof. Angle A plus angle B plus angle C plus angle D equals 360 degrees. Okay. It says, for number 1, draw BD, and then it says Y. And then it says what my answer was 2 points to determine a line. Isn't that right? Point, line. Okay, now we're going to go to 5. Angle A plus angle ABC equals, sorry guys, let me redo that. Angle A plus angle ABC plus angle C plus angle CDA equals 360 degrees. Why? My answer to question 5 was substitution. I don't know if you guys remember, but you guys should. But back then, we had, not back then, but a while ago, we had lessons, chapters, and sets about, we had substitution, addition, division. In fact, the answer to number 3 and the answer to number 7, addition, and then division, 5 substitution. There was multiplication, subtraction, which I'll eventually get to you guys because I think I said subtraction in one of my other questions that we're going to move along to. Okay, next we're going to go to our little set called corollary. Complete the following proof of the corollary to theorem 24. A quadrilateral is equiangular if it is a rectangle. Prove that if a quadrilateral is equiangular, it is a rectangle. I'm about to show you all of our rectangles. We have 2 actually. And then I'm going to just read you the given and proof right now. Given ABCD with angle A equals angle B, angle C equals angle D. Actually, I think I said that wrong. Angle A equals angle B equals angle C equals angle D. Okay, and then proof is ABCD is a rectangle. I'll show you it towards the end when I show you the picture. But why not show you now? And the next one we have the carpets one too, but I'm going to show you the rectangle. See, and then we have the n degrees. That's important to watch. Okay, number 6 is the proof. In the measure of each angle is n degrees. Then 4n equals 360. Why? And notice how I just said 360, not degrees. My question for number 6 was, the sum of the angles of a quadrilateral is 360 degrees. We're going to now number 9. So ABCD is a rectangle. Why? My answer for number 9 was a quadrilateral, each of whose angles is a right angle, is a rectangle. Okay, now we are going to number 11. So, angle A equals angle B equals angle C equals angle D. Why? My answer is all right angles are equal. 90 degrees here, 90 degrees here, 90 degrees up there, 90 degrees up there. Okay, but seriously, in real life, in Fahrenheit, that's hot. Okay, back on subject. Next one is carpets. I just showed you the picture of the carpets while showing you the rectangles. Okay, carpets. The photograph shows a freeway overpass under construction near Santa Barbara, California. Old carpets were used to keep the concrete from hardening too quickly. Carpets usually have the shape of equiangular quadrilaterals. 12. This one was easy, so you guys should know this by yourself. It says, what are equiangular quadrilaterals commonly called? Rectangles, am I right? We're going to go to question 15. Why are the opposite sides of ABCD parallel? I'm about to show you the rectangle up here. Why not I just show you? Up here. That's the ABCD. My question for number 15 was, in a plane, 2 lines perpendicular to a third line are parallel. Okay, we're going to another little set called rectangles. Each of the figures below is a rectangle. The diagonals are shown in blue. I'm about to show you them. I'm showing them now. Up here, down there. See? These two ones right here. I'm going to show you that too. I'll show you later. Okay. My answer to 16 was, what is always true about the angles of a rectangle? My answer was, they are equal and they are right angles. My answer to question 18, that the diagonals of a rectangle, they seem to be equal. Rhombuses. Next little set. Each of the figures below is a rhombus. The diagonals are shown in blue. The ones I just showed you too. Number 19, it asks, what it seems to be true about the sides of a rhombus. They seem to be equal. Number 20, the diagonals of a rhombus. They seem to be perpendicular. Next little set called squares. Each of the figures below is a square. They got medium size, bigger size, and small size. I'm going to show you the picture of parallelograms and then the SAT problem, just so actually I won't show you the SAT problem, but I'll show you the parallelograms and this square. Therefore, see, squares, medium, small, big, and then we got the big ones, parallelograms. See the photos too. Okay, anyways, let's get on. The answer to number 22, rhombuses, is they are equilateral. Okay. For parallelograms, we got each of the figures below is a parallelogram. The diagonals are shown in the blue. What seems to be true about the opposite sides of a parallelogram? My answer to that was, which was 23, was they seem to be parallel and equal. My answer to number 25, the diagonals of a parallelogram is, was they seem to bisect each other. And then for our SAT problem, I'm about to show you the shape. This one you gotta take seriously, because in high school, this one is important because when you guys be taking your SAT test and you don't know this, it's always good to get this workbook because they give you SAT problems that will be in your SAT tests. Let's get on with this one. Please make sure to watch this one through because I am going to explain everything to you and tell you all the answers just so you guys can lock it in a little better. For the SAT problem, we have the figure below appear in a problem on the SAT exam. Not much of a statement. Okay, I'll show you the picture in the beginning and in the after. It's very important that you guys get this one. That's 90 degrees here. 90 degrees here. Y degrees, X, and X. Okay. It says, what can you conclude about 26? 2x plus 2y, question mark. My answer for 26 was 2x plus 2y plus 180 equals 360. And then we got 2x plus 2y equals 180. Then we got, for 27, x plus y, question mark. X plus y equals 90 degrees. Because if you look at them, they're like half of it. So when you put it together, 90 degrees. And guys, to make sure you guys understand all of this, I want you to go through the photos in the beginning. And if you need to pause anything, remember to do that. So guys, let me go now to the back extra. Anyways, see you to the next Abby. Okay, so guys, I'm so sorry that now we're in the extra. Anyways, I hope you guys enjoyed our geometry set. Please make sure to like, subscribe, and to comment to make sure we know how to make our videos better, funner. Anyways, thank you guys for watching so much. And please make sure to watch all of our other videos. If you guys maybe want, we'll maybe start a new YouTube channel for just geometry and math sets called Geometry Point 101. Help us think of a name, guys. But I really, guys, hope you enjoyed this. Make sure to study always. And make sure to keep a bright smile on your face.